Hello. So a person doing chin-ups weighs 900 newtons exclusive of the arms. During the first 25 centimeters of the lift, each arm exerts an upward force of 355 newtons on the torso. If the upward movement starts from rest, what is the person's velocity at that point? Okay, so I have my person here. He weighs 700 newtons, and each arm pushes up 355, and that's each arm. And he has two, so we have to multiply it by 2. That's in newtons, by the way. So the overall force that's going on is 710, which is this, minus 700 equals 10, and that's newtons, the overall force. So to find velocity, a good thing to have would be acceleration, because then we can use one of the kinetic equations. And we can figure what acceleration is by using force equals mass times acceleration. We already have the force, that's what we just solved. So 10 equals mass. So to figure out the mass, we can use the weight and divide by the acceleration due to gravity. So that's the weight here, and times a, what we're solving for. And what we find is that a equals 0.14 meters a second squared. Oops. Okay. So let's just get this out of the way. Cool. So now we can use a different equation. 2a times delta x, or the displacement, is equal to the final velocity, which is what we're trying to solve, minus the initial velocity. And it says that the movement starts from rest. So this is 0. We don't even have to think about that. So we just plug in what we solved for. 2 times acceleration, delta x. So that has to be in meters, but they tell us that it's 25 centimeters of the lift. So that in meters is 0.25 equals VF squared. And if you multiply things together, you will find that VF is equal to 0.7. So just take the square root of both sides, and you'll find that the final velocity, which is what we're looking for, is about 0.2646, and that's in meters per second. Thank you.